Hello, how you doing, man? I'm Hamish, or sometime other people that call me Mtwana or Bantu. Let's get started, man. So we don't want to waste your time. So let's say here simplify. So this is more of exponential and radical and power and the base. Okay. So now, before we get started with this question, I want to show you the rules because with this one it's more of the rules. So if you don't know the rules, and then it's not gonna make a great sense. So let me take you to the little rules and there we go. So we have a rules of exponential here. Okay. So now. If you have something like this, for example, if you have, let's say, m p means m, it can be any number and this can be any number. I'm just taking some random variable. So this is the base and this exponential, but all of this together is called power. You know what I'm saying? So if somebody say, let's say 3 power 4, this is a base, so this is the base, and this one on top is exponential, exponent, sure. Oh, I'm gonna write here. Excuse what I'm saying? This spelling exponential. So now this is the base and this exponential, but all them together we call what? Power. Okay? Power. These all them together equal power. You know what I'm saying? So now the rules, the rules of exponential, whenever you have any variable power 0 equal to 1, anything power 0 equal to 1. For example, if you say Mtwana, but everything power 0 together with this 0, if you put them together, equal to 1, okay? That's what I say, all this stuff with the 0 equal to 1. Because sometimes, you know how people do, some of the students, how they make mistake, they say, oh, x power 0 equal to x power 1. No, it's not 0 equal to 1, no. With its 0 equal to 1. So not x power 1, because some people they say x power 1. No. That's wrong. It's everything with its 0 equal to 1. You know what I'm saying? So for example here they say QMI 15 power 0. So what is that power 0? The power 0 is not everything. Okay, the power 0 is only 5. So everything else is going to remain the same. So it's going to be Q. Okay, and that's going to become M I 1. So only this stuff is only power 0. The rest of the stuff is stay the same. So 5 power 0 equal to 1. So it's going to be power what? Power 1. So you see only this time 1. Everything stay the same. You see, but for this case here, you see everything in a bracket because this 0 is for all in a bracket. But here you see only the last number. Now let's go to the rules of addition. For exponential, whenever the base, these are base we know, when the base are the same, what you do, you add the power. So when base are the same, don't write the both base, no, you only write single base like they are the same. So I'm only gonna write 1 and then take this power, add them. Okay? So if is multiplication, so you write only one base here and then add the power. You know what I'm saying? For example, if somebody gives stuff like this, excuse me, let's say somebody give you, we have a 9x times 27 power 4. So base are not the same, but how I'm gonna make them the same? It's easy. So I'm gonna say this same is say 3 power 2, 93 power 2, but at times x is gonna be 2x, and this 27 3 power 3 means if you take 3 power 3 equal 27, but at this 3 times this 4 is gonna be what? It's gonna be 12. So you see now the base are the same. So when base are the same, you don't have to write both base. So I'm gonna say this, I'm only gonna write single base and then I'll add the power. Our power of the face is 2x and then we plus this, which equal to 12. So these are rules of exponential. If the base are the same, so you see at face the base were not the same. So I had to break it down so it can be the same. Now let's go to the division. What happened with division? When it's division, like here, okay, so if somebody give you t power whatever you have, you know what I'm saying? Okay, t power m, t power b. So the base are the same, but it's division now. So if it's division, whenever the base are the same, you only write single base. You don't have to write them both. So I'm going to write only 1 and then take the numerator minus the denominator. Let's take this exponential here, the one on top minus the one at the bottom. For example, I give an example here. So we have a 16 over 8 power x. So we have a 16, 3x. over 8 power x. So you see now the problem is the base are not the same. So if base are not the same means the rules cannot be applicable. Okay. So now let me break the base so that they can be the same. Now I'm thinking, okay, 16. Which number is going to be common for both? Oh, 2. So this going to be 2. 16 means 2 power 4. Only 16 is 2 power 4. 2 power 4 equals 16. Oh, can you put in the calculator, see? So that 4 you must multiply by 3x. So let me just go slow. 2 power 4 equals 16. But outside of here we have it 3x over 8. 8 means 2 power 3. Because 2 power 3 give us 8. And then we have an x here. And then, oh, so that case now we have another rule. If you have such a case, I can multiply this power. Remember, this is power and this is power. I mean exponential, excuse me. So it's going to be 2. 3 times 4 is going to be equal to 12x over, and this is going to be 3x. Oh, so you see now the base are the same. So when the base are the same, what you do, you only write single base, okay? So I don't have to write both base. I'm only going to write one of these. So I'll write 2. But remember, we have to take the power of the top, or we can call mathematical numerator, which is this power here, 3x, 12x, and then we minus the denominator. And this is going to give us 2 power 9x. So this is going to be 2 power 9x. Oh, now one more rule, and then after that we go to the equation. So another rule is called reciprocal rule. Okay, the reciprocal rule. Okay, so all these rules we know them. Now we go for the reciprocal rule. Reciprocal rule. Look, if somebody gave you something like this, okay, so what you do, you say, oh, reciprocal. How we do reciprocal? So we say, let's reciprocate. To reciprocate means, look, when there's no number here, which number is there prior to number? Means there's a 1 here when there's no number. So I'm going to say this is same as say 1 over, take everything to the denominator. So say x, the only thing you change, you see the sign here is negative, it's become positive 1. Okay, that's how you reciprocate. Means you take everything either to the top or to the bottom, but the sign of the power of the exponential change. So if somebody give me, let's say 4 a power negative 5. So this time I say I'll write my number, okay, and then I'll take everything to the bottom in this. So your focus has to be only in that power, okay. So the 4 just a number, has nothing to do with exponential, with the reciprocation. So we're going to take everything to the bottom, but you see the sign was negative become positive. Now let's see how we can reciprocate that question right here. So this is very easy. So what I'm going to do, you see, I'll take this to the top, because you see only the exponential. So it's going to be 7 over 2. 7 over 2 is going to see in each position, and then all this stuff is going to go to the top now, okay, because it's at the bottom. So we're going to take it to the top. So this is going to become x. You see this sign here is negative, so here when you reciprocate it's going to become positive. Same here, so it's going to become 6. See this one is going to go to the bottom, so it's going to be x is negative, right? So it's going to become positive half. So now we know all the rules of reciprocation. You know what I'm saying? Let's just do this in 1 minute, and then we go to the equation, and you want to be done with all exponential topic. Okay, so this one I just said before. Now you can just multiply in. You say x a b. So same here. So this time I say negative 5. Look, okay, so I'm going to say x negative 8. So this is going to be x and then negative what? 8, because I just multiply that out. But you know, when you finish your answer, you don't have to leave like that, because the answer, yes, is correct, but you know, it's not good to leave the final answer as a negative power. So this is MSA. Okay, this is MSA. I'll write my negative 5 here, but I'm going to reciprocate all of this. So what do I reciprocate? You reciprocate something, the power, okay, the variable which has an exponential. So all this is going to come at the bottom, which is going to be x power positive 8. You know what I'm saying? Yes. So for this case here, you see everything power that. So 3 power 3, 27. Y 3 and 3 is going to be 27. So I think you know all the rules. You know what I'm saying? So now we can just go straight and do the equation very, very quick. Okay. So now let's go back to the equation here. The equation is very easy. Look how I'm going to attack this. Okay. So what I'm going to do is see here, they say simplify and leave your answer is a positive answer. So first and foremost, I'm going to try to simplify what is inside the bracket from the rules of the grade 4-5. We say you have to do with the BODMAS. Okay. This rule say board mass, okay? Board mass. Okay, let me use another pen quick. Sorry. So we have a rule. It's called board mass. Okay? So the board mass rule say board mass. Board mass, okay? Shows me. Board mass. Means start with the bracket. Now you go, oh. So before anything, I must have to deal with something which is inside the bracket. So I need to deal with all this, okay? Now let's go. So now, before I go outside in the reciprocate, now 9 divided by 3. So I'm going to write my bracket. 9 divided by 3 equal to 3. You know what I'm saying? Now come here. So okay, and then see, these bases are the same. So if bases are the same, I don't have to write 2. I only going to write 1, and they take the numerator minus the denominator. So the denominator doesn't have a power. So but if it doesn't have a power, means power 1. So negative 5 minus 1 is going to be negative 6. So this is going to give us negative 6. Now we go for Z. The bases are the same. So only, you see, this and this is the same base. So I'm only going to write only one base. And to check the top 4, see, it's going to be 4 minus, but the denominator is negative 4. You know what I'm saying? So negative and negative is going to give positive 4 plus 4 equal to 8. You understand that? Because you take numerator 4 minus, but at the denominator, because the rule say, look, take the numerator power, which let me write here, is 4 minus the denominator. The denominator is negative 4. So negative and negative is going to give us positive. So 4 plus 4 equal to 8. Oh, so this is the power 8. And then you close your bracket and then negative 1. You know what I'm saying? So now you're going to say, oh, and then easy, man. So how are we going to do that? Say, okay, let's simplify what we have. So this time I say 3. Now look, bracket for both, power negative 1. So 3 power negative 1 is going to become 3 power negative 1. And then x power negative 6 times negative 1. So I'm going to write my x. And then negative 6 times negative 1 is going to be positive 6. And now you have z. 8 times negative 8 is negative 8. Okay? So then after that, we finish. The question is finished, but you know, you don't leave your answer as a negative what? Negative power. You know what I'm saying? Negative exponential. So I'm going to reciprocate all those negative values. Okay? So 3 power negative 1 is this. Let me say 1 over 3 power positive 1. Because if there's no number, makes it 1 times. So 1 times, take all this to the bottom. Okay? So x power 6 is just positive, so I don't have to reciprocate. But these, I'd rather reciprocate because power negative. So it's going to go to the bottom. So it's going to come here at the bottom. It's going to come to the power 8. So finally, okay, 1 times anything, it does something. 1 times x power 6 is x power 6 over 3 times that, it's going to become 3z power 8. Okay, so now you go to the option. Shows me just a second. Let me check the option, and that's going to be option 1. Thanks a lot for it. It is easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If it's time, make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects. You know, thanks a lot, man. I appreciate and I love you. Peace and love. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali.
Yeah.
I went to South Primary School.
Yeah, China with Bantu.
China with Bantu.
China with Bantu is everywhere, right? So this is my other student. His name, what's your name?
Matthew.
Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise, I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so try to about just everywhere, man.
I'm trying to about you everywhere. I'm trying to about you everywhere.
Everywhere.
Trying to about you
Exactly.
everywhere.
Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. It actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Ayapuma matoda yosi